All right, I want to look at the classwork today, how we can design a workable solar system. For example, a client has bought his materials, he bought the charge controller, he bought the inverter, he bought panels, and bought everything and has brought it before you as an installer. What do you expect to do? And that is the essence of this classwork. How we can design a workable system in the solar industry. Now, as you watch this classwork, the question is connect a solar system with 10 pieces of 555 watts, 69 volts, and 14 amps solar panels with the output to feed 48 volts inverter system. Now, in this 48 volt inverter system, remember that each of the panel gives you 69 volts, and the inverter, the charge controller inside the inverter as a hybrid inverter is the maximum power point tracking charge controller. So we want to look at how we can get this work executed successfully. Number one is that A, draw a well-labeled block diagram of the circuit. Now we want to draw the well-labeled diagram of the circuit. As you can see, this 55 watts solar panel, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have it. Therefore, we have to run the system of series to parallel connection. We have to employ the system of series to parallel connection. And this series to parallel connection, as you can see, two of the panels have been connected in series. These two has been connected in series. These 10 panels have been sectioned into 5 blocks. Now, in these 5 blocks, as series connection, remember that in series connection, the voltage increase and the amps remains the same. On that note, you have this positive now of one of the circuits to the positive terminal of the output, and this negative goes to the negative terminal. Automatically, what you have here is 138 volts. And how many amps? Because you connected in series, the amps remains the same. We have 14 amps as an output. But remember that you have not come to an end, the conclusion, because there are some about 4 are still on ground that you have not touched. Therefore, what we need to do is that this block also will connect it to the positive and negative to the negative. Therefore, automatically you have increased this to 28. This one has gone to 28 amps. But the voltage still remains the same. Now, you pick this particular negative to negative and positive to positive. You have increased from 28 to 42. The amps keep on increasing from 28 to 42 amps. Now, remember the two starts. We increase it, we add it up again. That this positive goes to this and the negative also comes here. By doing this, you have increased this to 56 amps. 14 plus 42 is 56 amps. And now you add the last stack. So what? Positive to positive and negative to negative. We have increased it to how many? 70 amps. Therefore, from what we have done, the block diagram of the circuit is this. We have gotten the block diagram of the circuit, and by doing this, you realize that you are on a safer side. Why do I have to say so? In case of shading, if this particular place, this particular panel is shaded, the panel will see, in fact, the client will not even notice the error. Why? Because this particular panel, this particular circuit ceases to work, but the output will just drop by the 14 amps. The remaining one will work perfectly. That is one of the advantages of series to parallel connections. Because parallel connections, shading will not, or one of the circuits, one of the panel has an issue, will not affect all the circuit, but the circuit will still working as if everything is okay. It's just that the amps dropped. So if this one is shaded, this particular two panel is ceased to work, while the remaining ones are working effectively. This is one of the advantage of it. Now, with this block diagram, question number B, and it says calculate the total output current of the system, of which we have done already. The total output current of the system is that 14. Remember now that this circuit has the amps remains the same. 40 amps plus 40 amps plus 40 amps plus 40 amps plus 40 amps. And that is to say 14 amps C. 14 amps times 5 is equal to 70 amps. At this point, you can guess the charge controller that will be inside that system. Or if you are buying a charge controller by yourself, you will buy the charge controller that will be between 100 amps and 120 amps charge controller to handle this particular system. Why? Because the sun rising and sun going down, you are not the one to determine it. So at the peak of the sun, the amps may arise more than 70, and that is why we use the tolerance. We now using the tolerance of 50%. When you use the tolerance of 50%, that is to say 50%, 70 plus what? 35. At the end, you have 105 amps. At the end, you have 105 amps as a charge controller that you will use based on this circuit. So, this is how to calculate it. Now, the number C is that state the type of connections used in the system to achieve a good result. And that's why you need to look at it. What is the system we use? Here we use the connection we use here is series connection. Here we use series connection. Here series connection. Here series connection. Here series connection. And when we use series connection, we now bring them together with parallel connection. And as we bring them together, we have the system we use as our answer to question number C is that the type of connections used in this system is series to parallel connection. Do you have any question in this regard? Please, we will be having a live video very soon. In the live video, you can drop your questions. Just note it, drop your questions, and right there in that live chat, you will answer immediately. It will be an interactive session. Thank you. As you follow us, don't forget to subscribe. Don't forget to like and don't forget to share. Thank you.